So this lesson is about electrostatics, which deals with the charges which are not moving. The charges, moment they flow through, it will constitute electric current, which is altogether a different topic. So this is electrostatics. So let's see what is an electric charge. It's a property of matter due to which a force of attraction or repulsion occurs. You can charge a body by means of induction or by means of friction. So let's see how to charge a body by means of induction. Take an uncharged body and bring a charged body near it, which is negatively charged. The near end will acquire positive charge and the far end will acquire negative charge. The moment you connect it to the earth, negative charges will flow. Now you disconnect the earthing and also remove the conductor. You leave behind with this uncharged body with uniformly charged, positively charged, and thus you can induce charges by method of induction. By method of friction is about rubbing a glass rod with silk or a glass rod with fur. When you rub a glass rod with fur, the glass rod will gain a negative charge and the fur will become positively charged. And when you rub a glass rod with silk, silk will require negative charge, the glass rod will become positively charged, just the opposite of it. Thus the charge remains conserved. That's the charge gained by the one is a charge lost by the other. So now let's come to the properties of charge. What are the properties of charge? One is additive nature of charge, second is quantization of charge, third is conservation of charge. Then unlike charge repel, like charge attract. Unlike charge attract, like charge repel. And unlike a mass, the charge does not change while in motion. So let's look at additive nature of charge, which is Q is equal to Q1 plus Q2 plus Q3 dot 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 Qn. Supposing a body consists of Q1, Q2, Q3 charge particles, the net charge is the algebraic sum of all the other individual charges, known as additive nature of charge. Quantization of charge is Q is equal to plus or minus n into E, where a body consists of n number of charge particles, all of them of a uniform charge. You can just say Q is equal to plus or minus n into E. The plus or minus indicates that the charge may be an electron or a positron, and the value of E will be 1.6 × 10 to the power minus 19 coulomb. Next is conservation of charge. You know that net charge remains conserved in the case of glass rod rubbed with fur or glass rod rubbed with silk. You can also say this example of uranium-92 getting bombarded by a neutron gives you a barium and a krypton with 36 and 56 as atomic numbers plus 3 neutrons plus energy, and thereby the net charge remains conserved on the left hand side and right hand side. Might as well know this so that it's useful when we learn nuclear fission. Uranium-92 238 when getting bombarded by a neutron gives you barium, which is 56, and a krypton, which is 36. 56, and the top of it you will have barium as 141, which is atomic mass, and krypton will have 92. Just memorize this. Thus you have 3 neutrons also. Thus if you see the atomic number on the right side and left side will be the same. Thus the charges remain conserved. Unlike charge will attract and the like charge will repel as the next point. Okay, the last point is, unlike mass, the charge does not change while in motion, because the mass will keep changing as per the theory of relativity by an equation m is equal to m naught by root of 1 minus v square by c square. This is by theory of relativity. The mass keeps changing once the body starts moving. Theory of relativity. Einstein relativity, okay, where m naught is the static mass, m is the moving mass. But the charge does not change. Why am I talking about mass? Is I need this equation in the case of cyclotrons, so might as well learn about the mass. Okay, then we dealt with certain sums based on Q is equal to plus or minus n into E. Okay, where they would have given you say 10 grams of copper. In that case, you'll write a given mass by molar mass into Avogadro number will give you the number of atoms, and you want you will only get the number of atoms, okay, and you want to get the charge particle. Each atom will have so many charges, right? Say the atomic number, so you'll have to multiply that with the atomic number Z, so that you get the total number of charge particle. I forgot to say this yesterday. I just said number of atoms. This number of charge particles is n. So you have to find how many number of atoms, multiply it with Z, which gives you the number of charge particles, and then put it here and multiply it with 1.6 × 10 to the power minus 19, so that you get the total charge present in 10 grams of copper. So that's about it. And we also dealt with some where they had given you the charge, total charge. They want to find the number of charge particles, just divide it by 1.6 into the power minus 19. You immediately get the number of charge particles in that case. Okay. So then next is we know one electron has a charge of 1.6 into the power minus 19 coulomb. 1 coulomb will constitute to how many electrons? Do this apple, you will get 1 by 1.6 into the power minus 19, which will be 10 to the power 19 by 1.6, which will be 10 to the power 20 by 16. You will get an answer 6.02 into 10 to the power 18. That many electrons is what is constituting to even to 1 coulomb of charge. So this is what we dealt with yesterday. And next is Coulomb's law of electrostatics, where the force between two charges, force may be attractive or repulsive, which is directly proportional to the product of the charges inversely proportional to square of the distance between them. Supposing a charge q1 and q2 separated by distance r, this is the formula. F is equal to k into q1 q2 by r square, where small k is a proportionality constant, which itself is 1 by 4 pi epsilon naught into q1 q2 by r square, whose value itself is 9 into 10 to the power 9 Newton meter square per coulomb square. Can you see Newton meter square per coulomb square will be k's value. It's a small k, or 1 by 4 pi epsilon naught. What is epsilon naught stands for is permittivity, absolute permittivity, absolute permittivity. In the case of magnetism, it will be permeability. Here it's permittivity, whose value is absolute permittivity is a how many electric field lines can pass through the specific medium is absolute, through vacuum is absolute permittivity, which is 8.854 into 10 to the power minus 12. Unit will be per Newton per meter square and coulomb square, the reciprocal of this, because epsilon naught is in the denominator. So now you have to know that I am going to talk about capital K, which is the dielectric constant. Please don't confuse yourself with the small k constant here, which is 9 and 10 to the power 9. This is totally different, which is force in vacuum by force in medium. Force in vacuum is 1 by 4 pi epsilon naught into q1 q2 by r square. The same charge, same distance when placed in medium will be epsilon into q1 q2 by r square. Everything will get cancelled and you will have epsilon by epsilon naught, which will also called epsilon r, relative permeability. Epsilon r is also known as dielectric constant K. See the terminologies. Relative permeability, dielectric constant is a ratio of permittivity in the medium to permittivity in vacuum. So therefore the permittivity of any medium is K into epsilon naught, or epsilon r into epsilon naught. Epsilon r will be available in your Clark's table. So that is what is, you understood what is a dielectric constant. Okay. Now coming back to Coulomb's law, now let's do vector form of Coulomb's law, where you have x, y and z axis. You have a charge particle q1 and q2. q1 is at a position vector r1, q2 is at a position vector r2. The directions have been given. The q2 will exert a force on q1, which will be force on 1 due to 2 f12 vector, whose position vector will be measured from r21. This will be the direction. So you know from triangle law of vectors, r2 plus r21 vector will be equal to r1 vector, hence r21 vector is r1 vector minus r2 vector. So thus you know the distance between the two bodies, which you have to put in the case of Coulomb's law. So F is equal to 1 by 4 pi epsilon naught, or q1 q2, q1 q2 1 by 4 pi epsilon q1 q2 by r21 vector the whole square into r21 cap, because when you square the vector, it will become magnitude. So you are multiplying with the r21 cap, which is a unit vector whose magnitude is just 1. It will just give you the direction alone. So this is f1 due to 2, f12 vector. Now you can write this as 1 by 4 pi epsilon naught into q1 q2 by r1 vector minus r2 vector the whole square into r21 cap. You can also write this as 1 by 4 pi epsilon naught into q1 q2 by r1 vector minus r2 vector the whole cube into r1 vector minus r2 vector, multiplying and dividing, so that it remains to be in vector form. So this is f12. Now so therefore this is also f12 vector. So let's take this as the final equation. Now we can, there will be a force exerted on the second particle due to the first particle, which will be 1 by 4 pi epsilon 2, ade q1 q2, but it will be r2 vector minus r1 vector the whole square into r12 cap. So in that case, you can also multiply and divide by 1 by 4 pi epsilon q1 q2 by r2 vector minus r1 vector, the whole cube into r2 vector minus r1 vector. You can write as magnitude also. So it still remain to be in vector form. You can take this supposing as a final equation. You know r12 vector is minus of r21 vector, and hence a force F12, F21 will be negative of F21. Equal and opposite force, and equal and opposite because charges are also the same. And so then net force acting on the system will be equal to 0. Okay, so next is sums based on this, which is F is equal to 1 by 4 pi epsilon naught into, supposing two charges are same, q square by r square na where their force, they have already given the force to be they've already given the force to be 3.7 into 10 to the power minus 9 newtons, and the distance of separation is 5 Armstrong, which is 5 into 10 to the power minus 10 meters. You can just cross multiply, and this with Bala you can write 9 into 10 to the power 9 itself. So with that you can find what is q square directly. That was one sum. How many, but you are finding only q, but the question was how many electrons are missing, which means they are asking n, so you have to write q is equal to plus or minus n into E. They are asking n, you find the charge q and divide it by E so that you get what is n. I forgot to say this yesterday. Okay, so the two positively charged ions carrying equal charge repel each other with a force of 3.7 10 to the power minus 9 newtons, separation between them being 5 Armstrong. How many electrons are missing from each ion? Next one, the initial force was F when the distance was d, which is 1 by 4 pi epsilon naught into q1 q2 by d square. When the force became F by 3, 1/3 of the original force, what will be the new distance is q1 q2 by d dash square. Divide this and this, thus you get d dash square by d square is equal to 3. So d dash by d is equal to root 3. So d dash therefore is root 3 times the original distance. New distance will come.